Okay, in this part we're going to learn how to sketch the graph of a quadratic function by using some key points. So we know a few things that we can, from our last sections, that can help us sketch a graph. And one of those things is that the a value, if we notice that the a value is positive, we know that it should be a graph that opens upward and have a vertex that's the minimum. If the a is a negative, we know that we're expecting a graph that should be opening downward for the maximum for the vertex. If it's in standard form, we know that the c value should give you the y-intercept. And if we're looking for an equation to graph and we have a equation in standard form, we know that we can find the x-coordinate of the vertex using the negative b over 2a and substituting that in to get the y-coordinate of the vertex, and that would be a key point on the graph. Using the symmetry of the nature of a parabola, then if we know the y-intercept, we can match up another point that's directly across from the y-intercept on the other side of the axis of symmetry. And if the y-intercept is not a good point to use, because sometimes the vertex might actually be the y-intercept, then you can pick another value, another point on the graph by picking any x on either side of the vertex, plugging it in to get the y-coordinate, and then graphing its corresponding matching point on the other side of the axis of symmetry. And those can be some key points that you can use to help sketch a graph. We'll try a couple of examples. So the first one here is given in standard form. So if we want to find the vertex, we would use our negative b over 2a again. And in this case, the b is 2, so the negative of 2 over the a is 1. So that would be negative 2 over 2, which is negative 1. And then your y-coordinate of the vertex would be negative 1 squared plus 2 times the negative 1 minus 3, which is equal to 1 minus 2 minus 3, which is going to be equal to negative 4. So the vertex is negative 1, negative 4, and then we can use our y-intercept. And to get the y-intercept, you just let x be 0. Or in this case, because it's in standard form, it just would be the c value. So y equals negative 3. So if we plot those points, we've got 1, negative 4 right here. And then 0, negative 3 on the y-axis. So then using symmetry, we know that if there's one point, if you go over 1 to the right and up 1 to get the y-intercept, then if you start at the vertex and go over 1 to the left and up 1, there should be another matching symmetrical point for that y-intercept. Now that's not a real good sketch of the graph if we just use those 3 points there. So in this case, we might want to pick another x value. I'm just going to pick x equals 1. So if x equals 1, y equals 1 squared plus 2 times 1 minus 3, which would equal 1 plus 2 minus 3, which in this case would be 0. So we know that 1, 0 would be another point. So again, from the vertex, we went over 2 units to the right, and there was a point up 4 units from that. So if we do go 2 units on the other side of the vertex and go up 4, we should get another matching point right across from that. So that helps us draw our graph just a little tiny bit better. So the next equation, we basically follow the same pattern. The vertex, we want to use x equals negative b over 2a. Can I erase that? No, too late. So this would be negative b over 2a would be negative 12 over 2a would be 2 times 3, which would be 12 over 6, which would be 2. So the y-coordinate of the vertex would be 3 times, instead of x, we're going to put in 2 squared minus 12 times 2 plus 4. So that would give us 4 times 3 is 12 minus 24 plus 4, which is negative 12 plus 4, which is negative 8. So the vertex for this graph is 2, -8. And our y-intercept is another key point. So if we let x be 0, and this again is in standard form, if we let x be 0, the first two terms are going to disappear, and you're just going to be left with the constant y equals 4. So we plot those points, 2 with -8, and 0 with 4. X is 0 goes with 4. Then we can use symmetry. So here's our line of symmetry going right up. So if there's, this would be where our line of symmetry is right here. So there's a 0.2 units on the left of that, so there should be a 0.2 units on the right of that as well. And this would be our graph, a rough sketch of our graph. I'm really sorry about the graphs, they look so bad, but I can't draw very well with this pen. Okay, so the next one, same idea. The vertex would be x equals -b over 2a, which will be the negative of -6 over 2 times the -2, which is going to be 6 over -4. Or you might want to put this in decimal form, so -1.5. And then if you plug it in, that would be -2 times the -1.5 squared minus 6 times the -1.5 plus 3. If you work that out, use our calculator now. So -1.5 squared, and then we're going to take that and multiply it by -2. And then we're going to, so that would give us -4.5. And then 6 times, or -6 times -1.5 is going to be plus 9, plus 3. So that would give us 7.5. So our vertex is -1.5 and 7.5. And our y-intercept, again, would be, when you plug 0 into the equation, you're going to get the constant 3. So we just plot those points, -1.5 and 7.5. So -1 is here, so -1.5 would be between -1 and -2. And then 7.5 would be between 7 and 8, so around right here. And then we have the y-intercept of 3, which is right here. And that's 1.5 units away from the axis of symmetry. So if we take the go to the axis of symmetry and go 1.5 the other way, we should get a corresponding point. And that's probably enough points to draw a rough sketch of the graph. You can plug in another point if you want and see what the y-coordinate is and do its match. Alright, the last one here now has y equals -x squared plus 7x minus plus 10. So again, vertex, we want x equals -b over 2a, which in this case would be -7 over 2 times a -1, which would be 7 over 2, because the negatives would cancel each other out, and that's 3.5. So then the y-coordinate would be negative of 3.5, 3.5 all squared, plus 7 times 3.5, plus 10. So that would be 3.5 squared, which is negative 12.25. 7 times 3.5 is 24.5, plus 10. So when you add those up, negative 12.25 plus 24.5 plus 10, you get 22.25. So the vertex would be 3.5 and 22.25. And the y-intercept is another key point, and the y-intercept in this case would be y equals 10. So plot that first, y-intercept of 10, and the vertex of 3.5, which would be, there's 3, so 3.5 would be about here, and 22.25 would be somewhere around here. Now, we want to graph another point that's symmetrical with a 10, so that's like 3.5 units to the left of the axis of symmetry. So you'd want 3.5 units to the right. So that would be 1. There's the half from the symmetry right here. There'd be half, and then 1, 2, so approximately somewhere around there where I've got the vertex. The graph grid is not out far enough. So your graph would go something like that. I mean, you can pick other points just to make it a little bit more accurate, because I'm probably a little bit skinnier than I should be up at the top, but it's really hard to draw graphs on this thing, so I'm then going to leave it at that. Okay, so if we look, this is the end of this section here now, so you can try number 11A on page 334 for extra practice.